Hello, this is my explanation for the graph data type checkpoint. All right, so I will try to keep this a little shorter than my last video. So question 1, it basically is giving us this like directed cyclic graph, and it's saying basically starting at node A, in which order will the nodes be visited using the DFS, like depth first search. So basically the node order I said would be A, D, E, B, G, H, C, F. Essentially how I got to this was drawing out the graph myself and then basically going down each path to the very end. So basically the first path would be A, D, E, B. We hit the end of the node. Okay, next neighbor in alphabetical order is G. So then from A we go to G and then we hit the end of the graph. And then from there we go H, and then because it's alphabetical order, we visit the next neighbor, which is C, and then F, which is the end. So that's how I got to my answer for the DFS question. The second question asks this basically in terms of a breadth first search. So again, starting at node A, basically we look at A's neighbors. So we say A, D, G, H. So that's the first 4, right? So now we're gonna look at the neighbors of D. And looking at the neighbors of D, we just get E, 1 away. Next, we look at the neighbors of G, we find none. Then we look at the neighbors of H, and from there we find C and F. And then next, we traverse, because we're at the end, we traverse back over D, back over E, and then we get B. So that's how I got the order A, D, G, H, E, C, F, B, basically using the breadth first search, essentially visiting all the nodes, neighbors, and then the neighbors' neighbors, and then the neighbors' neighbors, and so on. Okay, question 3. Given the same start node in an undirected graph, the DFS traversal order cannot be the same as the BFS traversal order. Okay, I said this was false because basically my reasoning for this is if you have a graph that's essentially just like linear, the BFS and DFS traversal order are going to be exactly the same. So they don't need to be different. They can be the same. So that's my answer, false. All right, question 4, basically given an unweighted undirected graph, this is basically asking which of the following statements are true about a shortest path between any two nodes, U and V, assuming neither of those nodes is a start node. So basically this was just process of elimination here. So I started out with the first one, says there can only exist a single shortest path from U to V, which is just not true because technically, right, if one node has, more than one edge coming out of it, and then it goes back to like U or V, like there can be more than one shortest path. I mean, if it's the same amount of edges either way, there's 2 shortest paths if the edges are the same number. All right, the second one says, let me see, sorry, my phone is covering my screen. A shortest path from U to V must include one or more edges in the shortest path tree from S. I said this isn't true because basically S is just finding the shortest path like from S to every other reachable node in the graph. And we know that, and S also is like starting from the start node, right? But we know that U and V are neither start nodes, so basically they could be really far away off the beaten path, for lack of a better term. And they could completely not intersect at all with S's shortest path, because S is just from start node to U, start node to V, but from like U to V, for example, they don't even need to interact with S. Okay, so I said that one was true, the second to last one. And then I also said the last one was true, the one that says the distance of a shortest path U to V cannot be greater than dis2 dot get U plus dis2 dot get V. This is because the distance is from S. So from S to U and S to V, there's no way that that is going to be greater than the distance from U to V, not including S, because that's from start node to U, start node to V, together, that's really long. And from U to V, it's just like a completely different deal. So that's why I said that one is true. So that is my explanation. Hopefully that was good. Thank you.